Oh my God. Okay, let's get started. Where are we even at now? My mind just got blown. All right. We're talking about HTML injection attacks. Should I give I think we just did a roadmap of the homework last time. Should we do another one? I think we're okay, but just a quick reminder, learning objectives 1 and 2, bless you, 100% in your hands. I'm done talking about them. Application objective 1, same thing. It's actually not 100% yet. I got to get to the /r/n demo. Maybe I can do that today. I might be able to squeeze that in today. The /r/n demo. And application objectives 2 and 3, we haven't started talking about it all yet. So up to application objective 1, you're good to go. Learning objectives 1 and 2, 100%, you're ready to go. It's all in your hands right now. So if you're getting started on the homework, you have everything you need to meet the expected deadline. That's all. The lecture content is out there. We're all ready. If you have questions about those, I'll be happy to field questions, but I'm not going to build anything. Like I just ran out of stuff in terms of lecture content to say. Everything's already out there. So that's where we're at on the homework. Today we're talking about security, I guess in a sense this is learning objectives 1 and 2 stuff. We have the security concerns that the submitted HTML shouldn't be rendered as HTML. So today we want to talk about what that security vulnerability means. So I guess I did misspeak. After today, then all of the learning objective 1 and 2 stuff is done. So we kind of got to cap off this topic. So let's talk about HTML injection attacks. So when we hosted static pages, we didn't have a concern with this. This was no security issue in homework 1 because we hard-coded all of the content that was being sent to the user. Users had no control over what they saw. They just requested our poster site, and we sent them our poster. No concerns, nothing. I mean, we did build in the no sniff, but we had full control over the content anyway, so we were just talking about headers for that. But now we're handling user-submitted content. This opens up a whole floodgate of security issues that we need to be concerned about. So now that we're handling user-supplied information, we're taking information from any user and displaying it to all users. So if one user can get an attack in that's going to compromise any other user or every other user, we need to be concerned about that. We need to be protecting against that. We need to handle this. If your answer is to trust your users, you're wrong. Never, ever, ever trust your users. Do not trust your users. Don't just say, my users would never hack me. No, do not trust your users. You cannot trust your users. You cannot trust anything that comes to your web server. You can't trust any information that gets to your web server. You must check everything. You have to sanitize everything. Do not trust your users. No, really, never, ever trust your users. Hopefully you've heard this somewhere else. Hopefully I'm not the first one to say this, and I won't be the last. Never trust your users. So why, though? I like my users. My users are great. They're never going to hurt me, right? You might be tempted to think that. The issue is, who are your users? How do we define users? If you've taken 442, which probably is very few of you, right? You would take this before 442. Never even to use the term user because it's way too broad. When you're collecting requirements for programming tasks, for your software, you don't use users just because it's too broad. It is very broad. So who actually are these users? Everyone. Everyone on the planet. I mean, not literally. If you have billions of users, obviously you have a really rock star app and everything. You have a fantastic app and you're a billionaire at that point. But it can be anyone. It doesn't have to be a legitimate user using your site for its intended purpose. It can be literally anyone with an internet connection. Anyone with access to an internet connection, which is most people on the planet. Do you trust most people on the planet? Billions of people? Do you trust every single one of them to do exactly what they're supposed to be doing when they're using your app? And furthermore, they don't even have to use your front end. They don't have to use your code that you give them. They can change your front end. They can write Python scripts that make web requests, that send HTTP requests. HTTP, we saw, is just bytes, and we're just using TCP. Now, a web browser is a convenient way to navigate the internet, to navigate the web anyway. But no one has to use that. They can write Python code just like you're writing a TCP server that acts as a web server. Somebody can write a TCP client that acts as a web user and start firing off requests to your site without using your front end. So they can send you anything. Or they could just open up Postman and fire off requests that way. I can fire off requests to buffalo.edu right now with Postman and not use their front end at all. We need to be protected against this. And it's not just hackers out there with nefarious intentions sitting there going, I'm going to get this CSE 312 project site that they had to deploy. I'm going to attack them and get them. It's not that. Usually not. Unless you're big and somebody's targeting you, like Google is getting targeted every day. But even if you're a small app, and you might think, well, who's going to attack little old me? Nobody's going to attack me. It's not that. It's that they have bots that are doing this. There are bots just scanning IP addresses. There are usually when you deploy, you're going to get an IPv4 address. And there's a lot of them. There's billions of them, but there's only billions of them. So you can write code that's just going to ping every single IPv4 IP address, and look for common vulnerabilities. So what they do is set these scripts up. They have them just scanning for vulnerabilities, scanning the whole internet for vulnerabilities. And whenever it finds one, it goes, ping, hey human, got one. And then they go in and attack. Or hell, they might even have a script to do the attack too. And just say, hey human, here's all the credit cards. Here's all the social security numbers. Here's all the sensitive information. They're just going to run those scripts, and you're just going to get flooded with bots. I actually had an app. It was a Q&A app for CSE 115, once upon a time, way back, probably 5 years ago by now. And it was an open source piece of software that I deployed that kind of mimicked Stack Overflow. Students could ask questions and get answers, and upvote answers, upvote questions, and things like that. And it worked pretty well. Probably should revisit that idea. Maybe not that exact software, but that idea again. And I went up to the class. I said, hey, here's the thing we're using. Here's the link on the website and everything. Go register for an account and whatever. And after the first lecture, I had several hundred students sign up. And it was like 300, 400 students in the class, I think, that semester. And I was all happy. Like, look at all the students registering. This is great. And then it got to like 500 registered users. I'm like, wow, even students outside the class are interested in this. This is kind of great. Like, everybody wants to learn computer science. Well, then it started hitting tens of thousands and hundreds of thousands, and I'm like, oh, shit. And it was just bots. I looked at the accounts that were being created, and it was clearly fake generated emails, generated names. And the bots were just hitting my website, my Q&A site for CSE 115. I'm like, why the hell are they attacking me? And they were just constantly creating accounts. Now, luckily, I did have it set to have to verify your email, so they couldn't make any posts. They couldn't really do anything, but they were creating the accounts and creating profiles. I found out later that what they were doing, they were creating their profiles, and their profiles would always have links to whatever site they were associated with, affiliated with. I suspect that it was an SEO company who was trying, you pay them to increase your SEO search results, and then they have these bots and these really shady practices which blast your stuff out using these bots and stuff. So they would have a link from a buffalo.edu site that links to this, whatever site hired this firm, and then that would increase their SEO ranks, because from buffalo.edu is a pretty good link to have, and then it would boost their results on search engines. So I'm pretty sure that's what was happening. So I shut it down. I added a CAPTCHA, and that was enough to block them. So unfortunately, CAPTCHAs are a thing that we have to live with, because Well, never trust your users. There's somebody out there who's going to abuse everything. Everything's going to be abused at some point when it's literally the entire planet of humans who can access this. There's no way that out of billions of people that 0 of them are going to act nefariously. Somebody's going to take advantage of whatever's out there. So you have to be protected. You have to be careful. And you have to be aware that literally anyone, probably running a script, can find your vulnerability. Like that one, they must have found, they must have known about that particular piece of, it was open source software, so they must have known about that particular piece of software and wrote a script looking for that vulnerability. Or more likely, that software used the library that they were attacking to handle login and authentication, and then they found that, and then it was bots from then on. It was like, I want to say hundreds of accounts per second. It was a ridiculous rate. It was a huge rate. 0-1 in homework 1, which I just do location hello when path is high, but in homework 2, when I need back to home page, since the home page is 8080, what should I jump to with my 301? Just location. You don't, oh, yeah, I see what you're saying. Yeah, exactly what you said. Yeah, so your 301, when you submit the form and you respond with a 301, respond with, or I don't think I specify 301, but a 300 level response. You should respond with location of just slash. Yes. So, with HTML injection, we expect users, we got a chat app, you put in your name, you put in your message, and we expect people to just chat and have a good time and share information and everything. And then somebody submits a message like this. They're going to inject JavaScript into your code and then have some JavaScript code which is going to just mess everybody up. That's either going to steal private data, steal cookies, change settings. It's going to do something that your users aren't going to like. Or the most, probably the simplest attack, maybe my favorite attack, if I were to do one, is a redirect. Speaking of redirects, actually, is just a redirect. Just reload this different page. So now anybody going to your site loads up the attack script and immediately redirects to some other page that the attacker chooses, which is probably some attack page with all kinds of JavaScript that's going to run and just try to steal everything it can. So somebody submits this as a chat message. You take that chat message as a string. You jam it into your database. Any other user visits your page. You pull that string out of the database. You have your HTML template. You jam it into your HTML. And then you send that final HTML off to that user. Well, that HTML has this malicious JavaScript embedded right into it. It came right from you, from your server, and then why wouldn't the client trust that? Why wouldn't the browser just run that JavaScript? It came from you as a full, complete HTML page, and it's got this JavaScript in it. It just looks like it's part of the site. But it was actually JavaScript injected by an attacker. So this is what we need to be protected against. This is what we need to watch out for when we're handling user-supplied information. Luckily, it's really easy to prevent. There's not even a lot of slides today, because this is it. This is what you got to do. To prevent this attack, whenever you have user-supplied information, escape the HTML. So when we talked about HTML, I mentioned there are certain characters that have these escape codes, or in general, you can use this ampersand and the semicolon. You can use the syntax to insert any UTF-8 character. And some of those characters have special names, special variable names, so we can easily escape them. We're going to use 3 of those today: LT for less than, GT for greater than, and AMP for ampersand. So with these 3 characters, we're going to escape these 3 characters into their escaped HTML counterparts. So now, instead of treating these as these actual symbols, they're going to be treated just as the UTF-8 characters that we want them to be. So we're just going to replace, with a find and replace, we're going to replace all of these characters with their escaped values. Without these 3 characters, try writing any valid HTML, much less getting a script tag and writing some valid JavaScript. not going to happen. Without less than and greater than, you can't have any tags. Without any tags, you can't create HTML elements, and from there you're just stuck. And then ampersand for good measure. I forget why we escape ampersand as well, but we do. In some libraries, you can even escape single and double quotes. Personally, I think that's overkill. I don't know how somebody's going to attack with just quotes, but not these three symbols, especially less than and greater than. So when we escape them, those characters will just show up as the UTF-8 string counterparts and will not be rendered as HTML on the front end. Likewise, if you ever want to write HTML that contains any of these symbols, you have to use their escape counterparts. A lot of times, I just had this situation the other day. I have code that I want to display on the CSE 116 website, and it has less thans in it. It actually had type parameters, generics in Java because it's Java, and I have to have the angle brackets containing the type. So I have to escape those, ampersand LT semicolon, ampersand GT semicolon. So you got to escape those if you want these characters in your HTML, or else the browser is going to treat them as HTML tags, if you have both of them anyway. So on the other side of it, it's helpful to do these. So we escape these characters. The user sends this to us, but whenever we send this to another user, we're sending this, and then the browser renders this as a string and replaces the escaped characters with the actual characters. So users are going to see this. The browser will not interpret that as HTML, an HTML script tag containing JavaScript, which it would run. Are we allowed to use the HTML module to escape? I guess. I forget what I said in the past about this, but I don't care all that much. But I'll get to the code and I'll show you. I mean, if you don't use that, I'm going to literally show you the code that does it. So either way. Order is important here. Escape ampersand first. Always escape ampersand first. So when you escape greater than and less than, they contain ampersands. So if you escape less than, greater than, and then ampersand, you're going to get some jacked up HTML. You're going to get an escaped ampersand, then LT semicolon. I've seen this in students' code before. What you'll get is, after this is rendered and everything, you're going to get something that looks like this on your front end, and you're going to say, why isn't my browser treating these as escaped characters and showing me the character? Well, it's because you escaped the ampersands. It'll replace the ampersands with the literal ampersand, but then not treat that character as the ampersand. It's saying literal ampersand, not interpreting it as an ampersand, which means I'm about to put in a UTF-8 code for a character. Which is, if you want an HTML page that teaches about HTML escaped characters, for example, that's when you would use this. Then you could actually show the escaped HTML. So the order is important there. Do ampersand first. Okay. Okay. I have my, oh no, I don't. I don't have my server run because I want to show running it. I don't know why, but we're going to run this server just to show Docker Compose. I don't know. I forget why I did that. I made that decision when I was tired. But I decided to shut down the server and run it in front of you. So I'm running Docker to run this server. I'm going to go to my browser, which I should have right here. Load it. It works. And somebody decides to do, let's see if I can get a good one. Whenever I try to do these live, I mess them up, but I think it might be window.alert is what I always mess up. So this version of the server is vulnerable to this attack. and hey, I've just been hacked. So that as a proof of concept, I obviously just did an alert here. But as a proof of concept that I can type any code in there, any JavaScript that I want, it doesn't render, my message doesn't render as text because it's not text. It's actual JavaScript that was rendered to the page. So if I look at this element, when I ran my HTML template, I just grabbed whatever was in the database. If I can get there. Whatever was in the database, it's italicized for what it's worth, but the script was actually embedded in the HTML. It's not displayed because it's a script element. It just runs the JavaScript when that part of the page is loaded. So whatever JavaScript anybody wants to write, that's what's going to be rendered there. This is not what you want. I promise you it's not what you want. Oh, I have this labeled as image. I didn't even notice that. And also in the username, I've still been hacked. Make sure you're escaping the username as well. The most difficult part of this vulnerability, of protecting against this vulnerability, the hardest part is just remembering to do it. When you escape it in your comments, make sure you're also escaping it in usernames. Don't let somebody enter a username containing some JavaScript. Even if they have a valid message, make sure you're escaping both. Whenever you're taking text from a user that's going to be displayed to other users, or hell, even if it's not, maybe someday you will display it to other users, escape the HTML. So this, and by the way, my favorite attack is just this. It doesn't really break much on this site because my comments were at the end. But I just, anything, I got hacked again. Just completely broke the thing. All I did was an open comment, an HTML open comment. I opened a block comment. Now everything after that on the page isn't going to display. The chat app's completely broken until somebody realizes what happened and does a close block comment. That's my favorite because it's just so simple yet so effective. Just does so much damage for a couple characters. And we can see all that content here. It still is being sent. Everything's being inserted into the HTML, but everything that was in between those comments was just commented out. It's treated as HTML. So how do we protect against this? It is absolutely devastating. Is absolutely devastating to be vulnerable to this. This is one of the things where a lot of people know to check for this right away. Whenever I do a demo and lecture, if it's open to the class, that's like the first message that's going to be sent is something, bless you, something containing some HTML that they want to show. Sometimes they'll just make their text really big, try to. Sometimes they'll legit try to attack people. So let's just escape our HTML. So I'm calling escape HTML. Remember to do it on message and username. Here I'm just returning input. The code to replace those characters, it's literally straight up replace. Order matters. Do ampersand first. Replace ampersand with amp. Less than with less than. Greater than with greater than. That's it. What was asked in chat was, can we use HTML? It's literally the same thing. Except it does have the optional, you can replace quotes as well. But it's the same exact thing. You should, in practice, you should use the library. In general, especially when it comes to security, you should use the library call. In practice, I do use the library call, but I just want to show how it works, so I wrote the code there. Because if there's an update later on, if somewhere in the future, seems unlikely for this case, but somewhere in the future, somebody finds a way to inject HTML in a different way, as soon as you update to the latest version of Python, they'll update this, you update to the next version, and you're patched, and you don't even have to think about it. You just update, you get some notification like, hey, big security alert, make sure you're up to date on Python, because we just pushed some big security thing. You don't have to think about what that is. I mean, you should look into it a little, but you don't even have to think about what it is. They'll just add it to here, and you don't change your code at all. For this one, unlikely that this is going to change. But for more advanced security things, especially when we talk about hashing and cryptography, use the standard, not literally standard comes with the library, but use the library that is the industry standard for those things. For those that specifically hashing is bcrypt is the industry standard library that we're going to use for that everybody uses. So you can use the import HTML if you want to do that. I'm just going to write the code out here. Rerun this thing. I'm going to force stop it. Refresh. I shouldn't be hacked anymore. I blew away my data. How did those other ones not work? I swear I messed this up before, but I don't see how. So now I got that alert, and it renders as text. So if I look at the HTML again, all right, hold on, let me go to the network tab. So if I look at the response that I got from the server, it was rendering it for me. It's trying to help me out there. What I got from the server has the escaped characters, but when it's rendered to the screen, the browser says, oh, ampersand LT semicolon, that's the less than symbol. And it prints literally the UTF-8 less than symbol. It does not try to interpret this as HTML. So this isn't valid HTML. This is just a string with the crucial characters escaped. So the user doesn't know that we escaped the HTML at all. They just see what we want them to see, the expected, whoever typed into the chat, whatever they said. But we're protecting against HTML injection attacks by escaping those 3 characters. Any questions on this? And as always, the rest of the day is demo, so if there's something you want to see, let me know. The next thing I'll do is try to get the /r/n demo. I didn't plan on doing that today, but looking at the homework, I'm like, oh, I should really do that today. So if there's a hiccup, we'll get through it. Any questions on this before we move on, though? Because this is critical. If you don't do this, like if you don't escape your HTML, it's an auto fail on any objective that pertains to it, including on your project. Need to do it. Check for that. Oh, projects. When there's this vulnerability on a project, it drives me nuts. The hardest thing with this is just remembering to do it. I have the big red security word all over the homework whenever you need to remind yourself. So just go through the testing procedures. You get to that line and you say, oh, shoot, I forgot, and then you just do it. So even if you forget, you're still going to go through your testing procedures and catch it. But and on the project, even on the project, I'll have projects that are vulnerable to this. I don't know how all 5 of y'all forget to do it. That's or 4 to 6 rather. How do all of you forget to check that? Like at least one of you has to remember. It drives me nuts when a whole team, and that's a huge hit to your grade. Not so much this semester, I guess, but it used to be a huge hit to your grade when it was percentage based. To have that vulnerability and your whole project score tanks. All right. Well, there's somebody typing a question, but I'm too impatient. I got to go on. I do have this. No, it's actually in PyCharm. It'll be called break an image. Examples, break image. Okay. Let's break an image. So I'm going to open this image. I'm going to go up 2 directories, public image cat. So we're going into, let's close this, public image cat. It's this picture of a cat. Simple enough. We're going to break an image. All I'm going to do is what we did last time. We're going to read this image and then save it in another file. So if I run this, I have to run it from that directory, don't I? No, I don't. It's weird that I don't. So if I run this, I get my cat. So I'm just copying that image over into this file, into a new file. My image. I promise I am. Oh, bear with me for a sec. Parse request. Oh, parse request. Okay. Parse request, good. So the good way of doing things, I didn't break it. So I'm simulating that this is going to be coming across as an HTTP request containing the image, and then do all the things. When we parse this, I'm going to parse this in a bad way. Obviously, I'm not showing all of the code, but in a bad way, I'm going to split the image on /r/n/r/n. And then I'm going to get all the pieces that I need out of this. I'm going to extract the image and save it to output.jpg. So when I do this and split on this character, I think I get my cat here. I get my cat. So that you're usually going to get away with. Not in the homework, of course, because we're checking that. But let's do an even worse way. Some of you like to do this. When you first get an HTTP request, one of the first things you do is split on /r/n, and then iterate through the headers and check the headers, and then eventually get to your image. If at some point you're doing this, splitting on /r/n, well, that character, that sequence might be contained in your image, and you're going to split your image into pieces when you do that. So specifically, /r is the hex character 0D. So if we look at our ASCII charts, a /r is 0D and a /n is 0A, which is the byte sequence 0D, 0A, which in binary is this. The OB means this is binary, and then these are the 2 bytes. So if these 2 bytes appear anywhere in your image, and you're splitting on /r/n, you're going to blow your image apart. So when we parse this image, wasn't I printing these in binary? Let me do it again. So when I parse this image, if those bytes appear anywhere in the image, this /x, it'll be this. If this appears anywhere in my image, why didn't this? We got this. We will get this. Right here, I want to print binary. Print binary sample request dot encode. Do I not have to encode? Oh, because I already have it in bytes. It's fine. So that's going to give me the binary of this image. And I want to search that binary for /r/n. This way we should get there. Binary. So this is me just printing out /r/n. And then here's my image, the bytes of my image. And actually, that's the headers still. Here's my 2 /r/n's. So that's the end of my headers. And then right here, this scary one right here is after the end of my headers. This is going to be in the middle of my image. Now, this is a valid sequence of bytes. It's just 2 bytes. Those 2 bytes right next to each other, that's valid to have in the middle of an image using JPEG encoding. Nobody's going to tell you can't do that. Nobody says, hey, by the way, people who write JPEG encoding, you people who are writing the standard, and over in HTTP land, we like to use these 2 bytes next to each other to represent the end, like a new line character. So if y'all could just never use those 2 bytes in any JPEG ever, that's not how things work. It's just 2 bytes. It's just 16 bits in a row. And if those 16 bits in a row appear in your image anywhere, and you're splitting on /r/n as bytes, which we have to because we're working with images now, you're going to split that image in half. And you're not going to get your whole image. You're going to get a corrupt image like this. That's bad. You can't do that. So let's change this slightly. Let's not print everything to the screen. You'll have to take my word on it for this, or else I'll never get this printed. Print, comment, both of those out. But let's change the image to Goose here. Let's parse this in a good way so we can see a lovely cat. Oh, I'm still printing it. What was I printing in binary? Right there. Oh, that's how I had the example set up. So this is why it's hard to call an audible. So when I print it good, the image is a little messed up because I've messed with it quite a bit. But and I lost the original, unfortunately. But I get this image of actually Lana's cat. Hey, Goose, how's it going? But now, even if I do bad parsing, which was when we were splitting on /r/n/r/n, this image actually happens to have that sequence in it. So when I do bad, not even worse, even if you're just splitting on /r/n/r/n, we only get half the image. We split that image up. Once we hit that byte sequence, it's no good. And we can see we lost, I forgot to point this out, but we lost quite a bit of bytes of that image. We have it's hard to read, but 194K. And if we go to, we can even verify just on our file system, image Goose, it should be 8.2 megabytes. So we lost a lot of information in this image because we split on /r/n/r/n and lost a lot of information, lost a lot of bytes. Do not split on those characters. You're going to split up the image. And just to emphasize what the good one is, what I like to do is find the first occurrence of whatever my delimiter is, and then splice the string. I'm going to go from the beginning of the array up until I find that index. That gives me everything before it, and then do that index plus the length of the delimiter. I don't want to get these 4 characters in what I'm splitting, colon, and then nothing. That's going to give me everything after the delimiter. So if you just want to split on one occurrence of the thing, this is a way to do it. Or what a lot of y'all do is just dot split and then give it a second arg. If you do that, it does the same thing. Okay, any questions on this? Don't split your images up. Seriously, it's going to be an auto fail on the application objective 1. Don't do it. Don't do all that buffering code and then fall to this. It's not fun. Okay. And now that I got it on lecture, I feel a lot better that I showed you exactly why that is the case. Now I can get back to something that I did prepare in my brain before I got here. It's been asked for a bit, and I never find a good spot to put it. I don't know why I'm showing you that code. I never find a good spot to put it. Let's put it right here. this is where I'll start talking about it. I might revisit this from time to time, but this is I want to at least get it out there and start this conversation. So most of your web servers right now probably look like, and I would expect them to look like, one giant if statement. You have if, elif, 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 else. And your else is your 404 and all the elifs, and if, that's if the method is get for slash, and the path is slash hello, do this, if it's a post for users, etc. And you have all of your code in one giant method. That's kind of what's expected. That's fine if that's what you're doing. But I do want to show you a better way at least. First of all, if you are doing that, I would recommend at least splitting that into separate methods. Have one big handle method with all your elifs. And if it's elif, it's get for hello, then call a method that's going to handle that request. Having everything in one giant method is awful. You're probably feeling it already just on homework 2, but if you get to homework 4 and you're still doing that, you have one file that's over 1,000 lines of code, and it's impossible to find anything or see what's going on with anything in your code. At least split it into methods, and you can put those methods in separate files and organize things a little bit better. I would recommend at least doing that. Honestly, when y'all come to office hours, especially later in the semester with the one giant method server that's just one giant method, it's almost impossible to read your code, and we can't really help you at that point. And most of your bugs are just because your code is so unmaintainable and unreadable that you yourself can't read it and can't figure out what the bug is. If you organize it a little better, I just want to encourage you to do that. You made it this far. You know all about encapsulation and OOP and all kinds of other things. You know how to do this stuff. Please apply it even when you're not forced to. Eventually, someday, I might force students to in this class, just so you can experience a better way. But anyway, I want to show you how I set up my server, how I set up a Python server that's like your homework code. Now, a lot of this, you're going to see method calls that look like they just do all the stuff for you, like request here, which I'm not going to show. This is code that I wrote. I've shown this code before, and the students called me out thinking that I'm using libraries. I technically am using libraries, but they're libraries I wrote. The request class is right here. It's defined in this file. I can't show you it because it has all kinds of solutions in it. But let me walk through how this works. So when I create my TCP handler, I'm going to override the constructor, which is going to call the superconstructor, so I'm not destroying everything, but I'm overriding, but just adding functionality. I'm going to add some setup here, which I'm going to create a router and add a whole bunch of paths to my router, which I'll get to. That'll be the next thing that I talk about. But I'm going to set up a router, and when I get a request, most of this code doesn't do anything. I'm just printing things to the screen. Like most of these are just print statements so I can see what's going on. The counter is something I'll talk about in a different lecture. Here's where I'm actually reading data. And if I don't receive any data, that means the client closed the connection. I want to exit out. We talked about that. I'm going to call request. This is a class, and its constructor takes a raw request, parses the request line, and puts everything in variables. So I have the method, the path, the HTTP version, even though I don't read it, I still parse it, and all my headers in a big Python dictionary, and the body of the request as bytes, because I don't know what the request is for yet. I'm going to put that in bytes and just store that in a variable, instance variable in this class. And then I'm going to tell my router that I set up here, I'm going to tell my router to handle that request. I'm going to pass it the request itself, the request object of this type that I created, and self, which is a reference to this TCP connection. So when we send things, usually we say self.sendall, self.request.sendall, right? We usually call that. Well, I want to pass a reference to self. Self is a reference to an object. I'm going to pass that into the router, so whatever code ends up handling this request, it will have a reference to that socket, and it can call sendall through that reference. So I'm going to pass that reference. You know about references. You know about objects. You know about classes. You also, since just the time frame when you took 116, unless you're a transfer student, you also know about functional programming. So a route that we add in the server is going to take I did my setup and then I lost it. A route is going to take the method and path, a get, post, put, delete, and a path, what's the actual path, and action, which is going to be a function, which is going to be called when a request is received for this method and this path. So we're going to use functional programming and OOP. We're going to mix these things that you know and put them to good use to organize things. Recommended anyway, I'm not forcing any of this, but recommended to do at least something like this. It doesn't have to be exactly this, obviously. It shouldn't be exactly this. Make it your own. But this is how I set mine up. So a route is a method, path, and an action, and it has a few methods. Is this request a path match? I'm going to get a reference to a request. By the way, type hints in Python are a beautiful thing. You can basically add typing to Python. And I'm going to check if the method is the same as the method of the request. So the method I'm looking for, is this a request for the same method? If not, we're done already. If it is, then I'm going to check the path to see if it matches the request path, the path that was requested. I'm going to use regular expressions for this to give me quite a bit of power out of my routing. And I'm going to say if the path starts with the path that I'm looking for, is how that's read in regex, then I'm going to continue on. I need some regex here because we have like /image /whatever. I want to make sure it just matches my regular expression. I can't be looking for exact paths, especially using something like query strings. I guess we're not on the homework anymore. But if you have a query string, you can't look for hard code every single path. So I'm going to use regex to do some matching there to see if the path matches. And then if it matches, I'm going to call the action. I'm going to call the function that I have stored in this route. And my router, whenever it handles a request, it's going to go through all of the routes until one of them matches and then call its handle request method. If none of them match, I'm going to call my 404 path and have it handle the request. And again, I'm going to forward the request and the handler, where handler is a reference to that TCP connection, or at least contains the connection. So when I want to add paths, once all that's set up, when I want to add a path, I add to my router a new route for the method type, for the path, and then a function, which is what code is going to be called when I actually get a request matching that method and path.